To solve a triangle means to determine the measures of all three sides and all three angles. If we have a right triangle, we can use either a primary trigonometric ratio or Pythagoras' theorem. If we don't have a right angle, so we have an oblique triangle, we will need another strategy that we can get some of those missing measures, one of which is called the sine law. Now, the sine law, as you might expect, comes from this sine primary trigonometric ratio. I can draw the height in this triangle, creating two right angle triangles. And then if I want to find, for example, the sine of angle B, we can set up that ratio by dividing the opposite side by the hypotenuse. And then on my other triangle, if I want to find the sine of angle C, we can also divide the opposite side by the hypotenuse. I'm now going to rearrange these equations. So I want to get this divided by C and divided by B off the denominator. So on the equation on the left, we can multiply by C. C times 1 over C will cancel out. And then on the right, we can multiply each side by B. So we'll be left with C times the sine of B is equal to H. And then B times the sine of C is also equal to H. Now, if we have two quantities that are equal to the same quantity, therefore we know that these will also be equal to each other. So we can now bring those two equations together, and then we're just algebraically going to rearrange this. So if I want to isolate C, I'm going to divide the sine of B out, and I need to do that to both sides to keep it balanced. So the sine of B divided by the sine of B will leave me just with that one C. And then over here, we have B times the sine of C divided by the sine of B. So we've got lowercase b paired up with capital B. I now want to divide out that sine of C. So I'm going to do that on both sides again to keep it balanced. So the sine of C divided by the sine of C is just 1. And now we're left with C divided by the sine of C is equal to B divided by the sine of B. This is equal to this. We have a proportion. And you'll remember that we use capital letters to represent angle measures. We use lowercase letters to represent the sides. So always the lowercase letter is opposite from that angle. The lowercase letter is opposite from that angle. Now C is not the best letter to use, but this is a lowercase c, this is a capital C. So if we're looking, let's say, for side C, and we happen to know angle C across from it, as well as one other pairs of opposites, we can use this proportion to solve for the missing variable. With the sine law, you'll notice that we have either the lowercase letters on top or we have the angles on top. The sine is always attached to the angles, and you'll notice that we have a pair of opposites in each ratio. So at any given time, we're going to set one of those ratios equal to another ratio in order to solve for a missing side or angle. We tend to use the sides on top if this is the unknown we're looking for. We tend to use the angles on tops if this is the unknown we're looking for, but both will work. You'll notice that we're only ever taking two of those ratios at one time in order to create a proportion that we can solve. So if this is my missing variable, like any proportion, we're going to multiply the sides opposite from one another and divide by the other. In our calculator, we're going to enter, make sure you're in degree mode first of all, and then we're going to enter 23 times the sine of 28, and then you can press equals to get that value, and then we're going to divide that whole product by the sine of 74, and x is 11.23, etc. We normally round sides to the nearest tenth and angles to the nearest whole, but because it doesn't actually specify, I'm just going to give an exact answer here. In my next one, we're looking for angle theta, and again, we're going to multiply the two that are diagonal from each other that we do know the value of, and then we're going to divide by that 42, and that's going to give us the sine of theta's ratio. We're looking for that angle measure, so we need to take the inverse sine of that angle. So once you have that value in your calculator, you're going to leave it there, and then we're going to go second function sine, and then second function answer. So you can see above the negative key here, you have answer. So your calculator will take that entire value, substitute it in here, press enter, and now we've got the measure of the angle, which we normally round to the nearest degree, but again, I'm going to leave this as an exact value. Now that we're familiar with how to enter the ratios into our calculator to get the desired value, let's take a look at how to solve for the missing variable. So in this case, we're looking for angle x, and we can see that we do have a pair of opposites. So we have one angle, and we know the side opposite from it. What we're looking for, we also know the dimension across from that. So I'm going to take the variable we're looking for, and I'm I'm going to set that up on top, and then opposite from that is the side. And remember, because we're looking for an angle, we always take the sine of that angle. If I begin with an angle measure on top, I need to continue with an angle measure on top. So the only angle we know is 50. So we're going to take the sine of 50, and opposite from 50 is that 30 degrees. So again, we're going to multiply 22 times the sine of 50 and divide by 30. That will give us the ratio of the opposite side to the hypotenuse. So now in order to solve for x, we're going to take the inverse sine, so second function sine, and then again second function answer equals, and so x is going to be 34.17 degrees. Now we know that sine can be positive in both quadrants 1 and 2, but if we take a look at what's happening here, so this 34 degrees is the reference angle as well as my angle of rotation in quadrant 1. I could put a 34 degrees here to solve for that angle in the triangle. The other angle we would get, if the reference angle is 34 degrees, that means this angle is 146 degrees. Now we know that the sum of the interior angles in a triangle is 180 degrees. So if I take 146, because we know that even though this is acute, diagrams are often not drawn to scale. So let's say this is 146. If we were to add 50 to it, that's going to give us 196 degrees, which is already more than what we can have in a triangle, and we haven't even considered that third angle yet. So we know that in this case, our angle will be that acute angle of 34 degrees, and we're going to address what happens here a little bit more in the next lesson. Now in this next example, I'm given two of the angles originally, so I know that because the sum of the interior angles is 180 degrees, I can take 180 degrees, subtract 83 and 26 from it, and I know that this third angle is 71 degrees. That's the only possibility we have. Now we're ultimately looking for side x, and again we know the angle opposite from it, and we also have a pair of opposites here now. We can go ahead and set up the sine law. I'm looking for x, so we're going to take the sine of that 26 degrees, and then if I start with the side on top, we have to continue with the side on top. The only other side we know is that 53, and it is opposite from that 71 degree angle, and it's really important that you put your degree sign here. If you don't actually put degrees, it means we're working in radians, so just make sure we have that degree sign there, and then we can go ahead and solve for x. Now you'll notice as soon as you press sine, a bracket is going to pop up. You have to close that bracket before you multiply by 53, and then we're going to divide by the sine of 71, and then if you take a look at this, because we're working in meters, we know that side x will also be measured in meters, so it's really important that you also put the correct units on there. In our next example, we're asked to solve a triangle. They give us two angle measures and one side length, so we need to determine the third missing angle and the two missing side lengths. So the first thing you always want to do is draw a sketch, and it's not going to be drawn to scale, but you want to try to get it as close as you can. So we can see that we have two acute angles here, and I'm going to put the angles that are given to us on the base. So this is the base of the triangle, so we want to fill in those base angles there, and it doesn't matter which one goes where. So let's just say we put 44 degrees here. That makes that angle L, so I know that opposite from it has to be side L. And then if I choose to put N here, and again, it doesn't really matter, this is then going to be 53 degrees. So the side opposite has to be side N. So that makes this angle on top angle M. So our base is going to be side M. Side N is actually given to us. So we can take that 16.3 and substitute that in there. And then the easiest thing to do would be to fill in this missing angle first of all. So we can take the 180 degrees in a triangle, subtract the two angles we're given. That third angle has to be 83 degrees. In order to solve for L or M, we can set up the sine law for both. So let's maybe start with L. So L is opposite 44 degrees. We're going to have the sine of 44 degrees. Start with the side on top. We have to continue with the side on top. And the only side we know is that 16.3, which is opposite from that 53 degrees. When you put this in your calculator, again, remember you have to close the bracket after that sine 44, multiply by 16.3, press equals to get that product, and then divide that whole product by the sine of 53. And again, I'm just going to leave that as an exact value. And then when we go to solve for M, as much as possible, you want to use the original information. So because I do have a pair of opposites that's given to me, I'm going to set it up using that same pair. M is opposite that 83 degree angle. and then we can go ahead and set up our second ratio like we did for this one. We're going to multiply, divide by the sine of 53, and that will give us the value of m. And then at the end, just quickly check. If you take the smallest angle, we know the smallest angle is opposite from the smallest side. So this is the smallest side. And then we know that the largest angle is always opposite from the largest side. And so m is the largest side length. In our next example, we're asked to solve for the height of this triangle, and we can see that we have a right angle triangle here, but we need at least two pieces of information in that triangle to solve for height. So right now we have one angle. I need one other piece of information. So the easiest thing to do would be to figure out what that hypotenuse of our triangle here would be, and then that would allow me to use a primary trigonometric ratio. So if we take a look at this oblique triangle, we can see that we have this angle, but we don't know this side across from it yet. We can solve for that if we have another pair of opposites. We are given this side length here. Could we find the angle measure here? Okay, so if we take a look at this, we can see that we have supplementary angles right here that would add to 180. So if I take 180 degrees minus 45, that's going to give me a 135 degree angle right there. And then we also know that the sum of the interior angles in a triangle has to add to 180. So 180 minus 30 degrees minus 135 degrees is going to give me a 15 degree angle right there. So now I have a pair of opposites where I know this angle and I know this side length. We can use the second angle in order to solve for that side. The angle doesn't have a name in the sense that we're not told what the angle measures are, so I can choose any variable to label this. If this was, for example, triangle ABC, then you would choose a letter appropriate to that scenario. So in this case, I'm just going to put an X here, and whatever variable you choose, it's crucial that you label so that somebody looking at your work knows what side you're referring to. So if I label this X, X is opposite from that 30 degree angle, so we can go ahead and set up that first ratio. And then I start with the side length on top, I continue with the side length on top. So the only other side length we know is 12 meters, which is this length from here to here. And that is opposite that 15 degrees. So then we can go ahead and solve this, and don't round off until the very end because we're ultimately not looking for X, we're looking for H. So now I can see that I have a right angle triangle. Given this 45 degree angle, I'm looking for the opposite side. I now know the hypotenuse. So we can use a primary trigonometric ratio, in this case the sine ratio. The sine of 45 degrees is the opposite side divided by the hypotenuse. So keep that whole value in your calculator and then just go times the sine of 45. And when we do that, we're going to get a height of about 16.39 meters. In our last example, we're trying to calculate the area for triangle RST. Now we know that area of a triangle is base times height divided by 2. Again, I'm going to take one of these angles and put it as my base angle. So this is side R. And then I'm going to take my other angle, put it in the other base angle. So this is S. So this is T. Side length T has to be opposite from angle T. So I know this is 200 meters. So we know the base of that triangle. We need to determine the height. And if you take a look here, I cannot just split that 200 meters in half. This is not an isosceles triangle. So if those two base angles are not the same, do not just divide that base in half. We actually have to do some calculations. Because the only side length I know is the base of that oblique triangle, I'm going to get this angle opposite from it, which I can do by subtracting those other two angles from 180 degrees. And now if we can solve for either side S or side R, that will allow us to set up a primary trig ratio in order to solve for the height of that triangle. So it doesn't matter which one you do. I'm going to go with side R here. So R is opposite that 24 degrees, and then again side on top, 200 is opposite from that 95. So we're going to go sine of 24, close the bracket, times 200 divided by the sine of 95, and now we've got side length R. So if you take a look at this right triangle here, from my 61 degree angle, I'm looking for the opposite side. I know the hypotenuse. I can use my sine primary trigonometric ratio, and that will allow us to solve for the height. So we're just taking that whole value, don't round it off. So keep this whole thing in your calculator, multiply by the sine of 61. So we know that that's over 1. And now we've got the height of the triangle. So now in order to get the area, we're going to take that formula again. We know the base is 200. Keep that value in your calculator, and when you put this in, So because this is already in here, I would just go times 200 and then press enter. We need to calculate that entire product before we divide the whole thing by 2. And then when we do that, make sure you put appropriate units. So because we're dealing with meters here, it's going to be meters squared because this is the area.